Hello. Today you're going to watch a video on the product and quotient rules, which are notes number 3 in our packet, and they're located on pages 6, 7, and 8 of your notes packet. So if you could open up to page 6 there, we're going to look at some examples of exponents and make some observation on some patterns to learn some product rules that will help the problems go faster. So in the first example, in number 1, it says expand 10 to the 6th. So we're not really looking for what it's equal to. You don't need to evaluate it. We're just going to do 10 times 10 times 10 times 10 times 10 times 10. So here you see you have 10 multiplied to itself 6 times. Okay, now let's do the same thing in example number 2. So in this case, 10 to the 3rd means 10 multiplied to itself 3 times. So then in question number 3, where it says expand 10 to the 6th times 10 to the 3rd. Okay. 10 to the 6th means 10 multiplied to itself 6 times. Times 10 to the 3rd. So 10 multiplied to itself 3 more times. So if you notice, what does this equal? Well, this is equal to 10 multiplied to itself 9 times. So this is 10 to the 9th power. Okay? So when we see that 10 to the 6th times 10 to the 3rd, that's equivalent to saying 10 raised to the 9th power. So let's take a look at the next example. In the next example, we have a to the 4th. So in this case, the base is a variable instead of an exponent, but it shouldn't make any difference. You know how to write it out the same way. So a to the 4th is equivalent to a times a times a times a. And then question number 5 says expand a to the 5th. We know that that's a times a 5 times. So in question number 6, where it says expand a to the 4th times a to the 5th, well, that a to the 4th, we know what that looks like, multiplied to itself 4 times a to the 5th, multiplied to itself 5 times. So when we look at this as a whole, you see that a is being multiplied to itself 1, 2, 3, 4, 5, 6, 7, 8, 9 times. This is equivalent to a to the 9th. Okay, so what do you notice here? We see if we are multiplying two quantities that have the same base, in both of these cases the base here was a to the 4th times a to the 5th, the base was a. Up top the base was 10 to the 6th times 10 to the 3rd. So when we're multiplying two quantities with the same base, we can add their exponents. So right here in the box, it says when you find the product of two algebraic expressions with the same base, and that's important. It does need to be the same base. You can add the exponents and use this exponent with the same base. So you want to keep that same base and simply add the exponents. So the rule would be if you have a raised to the m power times a raised to the n power, this will be a, and the exponent would simply be m plus n. Okay? So let's see how we can use this rule to help us simplify some of the expressions that we have. So if you turn to page 7, at the top we have some expressions, and it just says simplify each expression, write your answer in exponential notation. So I don't actually want you to multiply it out to evaluate it, I just want you to rewrite it in exponential notation. So in number 7 we have negative 4 to the 2nd power times negative 4 to the 3rd power. The base, negative 4, is the same in each case. So if we're going to multiply 4 to itself twice and then 3 more times, it's equivalent to saying that this would be negative 4 raised to the 5th power. Because you're going to multiply to itself 5 times in all. 2 plus 3 is 5. In question number 8, we have 3 to the 6th power times 3. Well, if you just have a 3, you know that that's 3 to the 1st power. It's equivalent to that. So in all, this is going to be equivalent to 3 to the 7th power. You just add the exponents of 6 plus 1. Okay, and the same thing can occur with variable bases. It doesn't make any difference. Here we have a to the 23rd power times a to the 9th power. So we can simply add the exponents, and we're going to have a to the 32nd power. Okay, so what I'd like you to do now is press pause and try the next few exercises. Do 10 through 15, and then you can restart the video where I'll give you the answers and we can keep working on the exercises. So go ahead and press pause and try questions 10 through 15. Okay, now that you've tried questions 10 through 15, you can go ahead and check your answers. Number 10 is f to the 23rd power. Number 11 is 1.2 to the 7th power. Number 12 is negative 5 to the 6th power, and you absolutely have to write those parentheses. The negative 5 is the base and has to be in the parentheses. You know that anytime we have a negative base or a fractional base, we need to use parentheses. Like in number 13, it's 1/5 to the 17th power. 14 is negative c to the 12th power. And then 15 is 9 raised to the 23rd power. So I had you stop there because I want to do another example with you before you go ahead and try the rest of them. In question number 16, we have 6 to the 5th times 4 to the 9th times 4 to the 3rd times 6 to the 14th power. So here they don't all have the same base. So we can't simply combine all of them. We can, however, combine the ones that do have the same base. And because of the commutative and the associative properties, we can rearrange this. It's all being multiplied. So if I rewrite this as 6 to the 5th power times 6 to the 14th power, I can rearrange that order, times, and then I'm going to put 4 to the 9th power times 4 to the 3rd power. So I've simply grouped them differently. So now I can look at the first two and say, okay, well, 6 to the 5th times 6 to the 14th, those two do have the same base. So I can rewrite that, add the exponents. 5 plus 14 is 19. That's going to be 6 to the 19th power. Times, well, these two have the same base. So I can rewrite those. They have the same base, and I simply can add the exponents. 9 plus 3 is 12. So it's going to be 4 to the 12th power. So in this case, the original expression simplifies to 6 to the 19th times 4 to the 12th. And from there, I cannot simplify it any further, because 6 and 14 are not the same base. Okay? I'd like to do number 19 with you, because 19 is an equivalent example. It's just using variable bases instead of numbers. So b squared times c to the 3rd times b to the 5th times c to the 5th. So here I'm going to multiply b squared times b to the 5th. Those two have the same base, so I can simply add those two exponents. So I'm going to have b to the 7th power times, here it's c cubed times c to the 5th. So it's c, and I'm going to add 3 plus 5 is 8 to the 8th power. Okay, so now I'm going to stop this again, and I'd like you to try the rest of the exercises on this page 7. Finish these exercises. Okay, now that you've had a chance to try the rest of these problems, I'd like you to check your answers. Here, number 17 is 15 to the 3rd times 7 to the 6th. Number 18 remains the same. Nothing can be done there because 5 and 2 are not the same base. So you cannot multiply those two. You cannot combine them. So there's nothing to be done in that one. In number 20, you multiply 2 times 3. You multiply the coefficients. 2 times 3 is 6. Then you can multiply x to the 4th times x squared to get x to the 6th times y to the 8th. So the x has the same base and the y is the same base. Same thing in number 21. We have p to the 6th times q to the 5th. In number 22, 4 times 5 is 20. You can multiply those two. S to the 4th times S to the 4th is S to the 8th. And then t cubed to t times t to the 6th is t to the 9th. Now, number 23 hopefully looks familiar to you. Here we have multiplication on the outside of addition inside the parentheses. So this is an example of the distributive property. So here we can distribute the a, multiply the a to both terms on the inside of the parentheses. A times a is a squared plus a times b is just ab. So hopefully you remember that from last year. And then the same thing in number 24. We can distribute the b to both terms on the inside of the parentheses. So you're going to have b times a. You can write it as ba or ab. It doesn't matter because of the commutative property. Plus b times b is b squared. Usually you'll see it written ab though. Usually we write the variables in alphabetical order. So usually you'll see it ab times b squared, but it's the same thing as ba times b squared. And then the last question, number 25, if x is a positive integer, what does the value of x have to be in order to make this true? Well, we learned today that if you're multiplying like bases, you simply add the exponents. So that means 9 plus whatever x is will be 14. So you know from this, I know that you learned how to solve equations last year, you can subtract 9 from both sides and you know that x is going to equal 5. So the missing exponent is 5 in this case, which will make that equation true. Okay? Excellent. So let's try the last few examples on the last page. And this is a different example where now we're going to look at division. And based on the pattern you've already seen, you can probably predict what's going to happen. Here at the top of page 18, it says expand 5 to the 6th power. And you know what that looks like. That's 5 multiplied to itself 6 times. And then 5 squared is just 5 times 5. So if you have 5 to the 6th divided by 5 squared, what would that be? So here we have 5 multiplied to itself 6 times. And I'm going to write that in this form like this, divided by 5 squared. 5 times 5. So in this case, you know that you can divide 5 by 5. Well, 5 divided by 5 is 1. So here we can have 5 divided by 5 is simply 1. 5 divided by 5 is simply 1. So what remains is 5 multiplied to itself 4 times in the numerator. So it's 5 to the 4th power. So you can see what happened and think to yourself, what's really going on with the exponents here? So let's try a second example with variables. If you have y to the, so if you take a look at an example with variables, if you have y to the 7th power, you know what that looks like expanded. And then if you expand y to the 4th, that's y multiplied to itself 4 times. So if you have y to the 7th divided by y to the 4th, you can probably predict what's going to happen there. So if I write it out, y to the 7th divided by y to the 4th, and I'm going to write that out in the denominator. So when we divide that, first of all, we can simplify and divide. Here, y divided by y is 1. Y divided by y is 1 again. Y divided by y is 1. Y divided by y is 1. You might have called this reducing or simplifying. And then what's left in the numerator is just y multiplied to itself 3 times. So we have y to the 3rd power. So you can think to yourself, how did you get y to the 3rd power from y to the 7th divided by y to the 4th? So just like when we're multiplying, when you find the quotient, meaning the answer when you divide of two algebraic expressions, with the same base, again, that's important, it needs to have the same base, you can subtract, I'd like you to write that in, you can subtract their exponents and use this exponent with the same base. So if you have a to the m divided by a to the n, to simplify that, you can just simply do a to the m minus n power. Okay? So let's take a look at how that would work for the first few examples here. So here we have 2 to the 9th divided by 2 to the 6th. So I can expand that out and cancel, or I know that since they have the same base, which is 2, I can simply subtract the exponents. So this is going to be 2 to the 3rd power, because I'm subtracting exponents, I'm dividing. Same thing in the next example. Negative 7 to the 5th power divided by negative 7, which the exponent here is 1. When I simplify that, I can subtract the exponents. I have negative 7 to the 4th power. Okay? And then I'm going to jump down and do number 38 with you right now. Here, even if we have 2 variables, again, just simplify the variables that have the same base. I like to write them vertically, so I like to rewrite this h to the 6th times k squared divided by h to the 5th times k. And when there's just k, you know that's the first power. So I look at the first pair, h to the 6th divided by h to the 5th power. I can simply subtract the exponents. And I have h to the 1st power, or just h. And then k squared divided by k to the 1st. Subtract 2 minus 1 is just k to the 1st, or simply k. So the answer here would just be h times k. Okay? So why don't you go ahead, press pause now, and try the rest of the exercises here on page 8. Okay, now that you've tried the rest of the exercises, you can take a moment to check your answers for the rest of these. Make sure that you've used parentheses around the 5/8 in question number 35, and parentheses around negative p in question 37. Okay, and then I'd like to finish up question 41 through 43 with you. So in this case, you see you have 5 divided by x cubed times 3x to the 8th. Well, the 3x to the 8th, since the first one is a fraction, we can put that over 1 and treat that second one as a fraction. So when we multiply fractions, we simply multiply the numerators. So 5 times 3 is 15. So we're going to have 15x to the 8th divided by, well, x cubed times 1 is just x cubed. So now we can simplify this because we have x to the 8th in the numerator, x to the 3rd in the denominator, and then 15 just divided by 1 is just 15. So this will be 15 x to the 8 minus 3 is 5. So it's x to the 5th power. Because since we're dividing like bases, we subtract the exponents. Same thing in number 42. The first fraction is 5 divided by x cubed. And the second one, I'm going to put that over 1. So now I can multiply the numerators. 5 times negative 4 is negative 20. And in the numerator, I'm going to have x to the 6th divided by, and in the denominator, I'm just going to have x cubed. So when I divide that out, when there's no coefficient, you can treat that like a 1. So it's just going to be negative 20 divided by 1, or just negative 20x. Now in this case, the exponents are 6 and 3. I'm going to subtract the exponents. 6 minus 3 is 3. And then finally, the last one, I'm going to put that over 1 again, like we did before. So I'm going to have 5 divided by x cubed times 11x to the 4th. 5 times 11 is 55, x to the 4th, divided by x cubed. And then again here, I'm going to divide just the x's. They have the same base, so I'm going to end up with 55x. Okay, so that completes the notes for today. Please make note of any questions you might have, circle some problems that you had trouble with, and bring them into class so that we can talk about them together. All right, thank you very much.